In this lesson, we're going to talk about how to prove if two triangles are actually similar or not. So that's going to be our learning target, knowing the two ways that we can prove that two shapes are similar. So a couple of vocab words for today is similar shapes. Are shapes with congruent corresponding angles. That means the angles in the same position are exactly the same size. And proportional sides. Remember, proportional is all corresponding sides have the same scale factor. So if one side was 8 and it went up to 16, that's doubled. Then another side is 5, it should go up to 10 because it's also doubled. So corresponding same position, proportional same scale factor, and similar as if it has both those things going on. So let's go ahead and take a look at a basic scenario of similar triangles. So I have two triangles here, JKL and WXY. These are similar. We have a symbol for similar that we've talked about. It is this little squiggle, and that is the symbol for similar. So why are these shapes the same? Well, I see that angle J is congruent to angle W, and they're in the same position. Angle L is congruent to angle Y, and they're in the same position. And angle K is congruent to angle X, and they're in the same position. Also, when I try to discover the scale factor for each of the corresponding sides, I'm going to get the same scale factor. 10 divided by 5 is 2. 8 divided by 4 is also 2. And 12 divided by 6 is also 2. So the scale factor of these shapes is 2. And that is the same for all sides when they're compared to each other. So are these triangles similar? So two ways. Either look for congruent angles or look for proportional sides. So I'm not seeing any information on these two triangles about the sides. So let's analyze the angles. The first thing I notice is I have right angles. So I know that angle B is congruent to angle L. We also have vertical angles. So angle A, H, B is congruent to angle L, H, K. And since two pairs of angles in both these triangles are congruent, that means that these last angles, angle A, has to be congruent to angle K. So are these triangles similar? Yes, they are similar. Why are they similar? They're similar because all angles are congruent. Okay? Because I have all corresponding angles are congruent. Okay, let's prove if these two triangles are similar or not. So the way we're going to do this, since we do not have information about angles, we have information about sides, we're going to do this by seeing what the scale factor is. So I'm going to have to set up a few different little mini fractions, different ratios to see if the scale factor is the same. So my first one is going to be a 99 over 27, since those sides correspond. My next one is going to be 143 over 39. And then my last one is going to be 154 over 42. We're going to see what each of these equal. If the scale factors are all the same, then these actually were similar shapes. So 99 divided by 27 is 3 2/3. 143 divided by 39, also 3 2/3. And 154 divided by 42 is 3 2/3. So the answer here is yes. They are similar because of the sides being proportional. Let's test these. I do see S and P angles are congruent, but since R and T and M and Q are not congruent, I can't say these are similar because of angles. So let's test the sides. So let's set up each of our ratios. 26 would correspond to the 20 on the smaller triangle. 20 on the large triangle corresponds to 16, and 15 corresponds to 12. Let's see what each of these equal, and maybe the scale factor is going to be the same for all of them. 26 divided by 20 is 1.3. 20 divided by 16 is 1.25. And 15 divided by 12 is 1.25. So I see that these scale factors are not equal to each other. That's right, they are not equal. So the answer to the question whether these triangles are actually similar or not is no. Okay, I have one more example that I want to show you. So I'm given this kind of scenario where one triangle is inside of the other. There's a lot of information here, and some information is that we need is given, some of it's not. So I'm going to start to set up these proportions to find out if we have the same scale factor. The first obvious proportion that I want to set up is 99 over 44. The next scale factor I want to set up is 36 for the big triangle, 16 for the little triangle. And the last one I need to set up is 36 for the big triangle, but then I don't know for the small triangle. 35 is not for any side of any triangle, so I cannot use it. So to find that, we're going to have to do 63 minus 35. I get 28. So I'm going to do 36 divided by 28. Sorry, I'm going to do 63 divided by 28. Okay, 99 divided by 44 is 2.25. 36 divided by 16 is also 2.25. And 36 divided by 28 is also 2.25. So, yes, these two triangles, the bigger triangle and the smaller triangle inside of it, are similar because all sides are proportional. This is the way we would complete our similarity statement. J and J are corresponding, K and D correspond, and L and M correspond. Okay, if you have any questions, call me over and I will answer any questions you have. And make sure you hit the submit button so I get record of you watching the video.